Hello guys, Sohan here. Welcome back to another video. And after releasing yesterday's video, I've got a few requests that to explain this circuit. This circuit apparently uses an AND gate with a single with two transistors, which looks simpler. Let's see how simple it is. I need to shift the components now. Let's connect this to add a voltage source. Now thanks to you, if this works as a AND gate, then I'll be thankful, and it works. Let's change it to 200 ohms. Now what is the problem? The problem is this particular resistor. If it's too low, let's see, 1 ohm, all the current is passing through this point, and if it's too high, then what happens? This just dims the light, doesn't stop it. So we have to find a sweet spot. For example, let's try with 100k. It just dims this. 10k. One k. It just dims this light. Something like 200. So you have to be careful with this particular resistor, and since it works, let's try building an OR gate with this emitter to emitter and collector to collector. Now let's run the simulation. Works. But this is letting in too much current, which is I think we all agree to be waste. And let's add a high power, very powerful resistor. But in case of an OR gate, we can omit this particular value, and it still stays a OR gate. So what about making a XOR gate? $10K, have to change everyone to 10K. Now let's see what happens. Now let's connect the power source now here. Through a resistor. Connect this part to ground. This is the output of NAND. And this is the OR gate. Now let's do something. Let's combine these two outputs to form a XOR gate. Let's keep these lights and combine them using a AND gate. To connect the power now. Now this particular state should have made this one off, but this resistance is too low at 10K. It doesn't do anything. So what's the problem? The problem is here. We need to add some resistors here in this part also. Okay, before adding resistors, let's try with a ground here. Nothing happens. So this ground is definitely of no use, as some people said. Now we can see what happens. It's now performing like a XOR gate, but this input is dimming. See, this input is dimming like crazy. So there is not a clear way. We don't have a clear way how can we set this value. This creates some problems, because if this was a separate gate, this would create problem here, and when multiple gates are connected like this, even if I don't just use it, this all panels would have different currents and problems like that. It would have various problems. Just the end result would be the same. And also in this case there is some current going through this part, and I think an 1K resistor would solve that problem. It acts properly like a XOR gate. It also has less transistors, but it also creates some problems like dimming issues and all that, which we have to fine tune. And nowadays we don't have time for that. We just make these circuits and just print them in a circuit IC or integrated circuit. So these photolithography techniques won't work, because we have to simulate each of these billions of connections, which we can't probably do that. And all these resistance values we don't have to play with. We have to solve more equations. We can build this logic, but we just have to solve many equations and just end with that. At the end result, it is not a simpler circuit, it's just a more complicated circuit. So thank you for today.